Prova, sono io Harry, ok di ritorno, much more coffee. Has anyone ever seen a comic book called Too Much Coffee Man? TMCM, anyone come across that? No. Okay, yeah, I found him as like a bit of an idol when I was about 19 years old and once did this thing where I tried to drink as much coffee as possible. It was quite fun for about like 45 minutes, but then I got a headache. Fine. Okay. Welcome back, everyone. Thanks very much for coming back for the second half, which is going to be even better than the first half. Oh, you bet. It's going to feature all sorts of fun with maybe saving the things in the database. That's what we're going to do. And so the way I've kind of structured chapters 5 and 6 is that in chapter 5 we're sort of going to go deliberately wrong. And in chapter 6 we're going to correct those mistakes. Now what's happening in chapter 5 is I'm actually making a bunch of sort of quite obvious mistakes as a way of demonstrating that TDD can help get you out of trouble. And so I'm not, the way it happens is that I'm going to sort of follow along really blindly and not think ahead. And so the tests go do this, so I'm going to do this in the stupidest and simplest way possible. And it's going to be obviously a blind alley. So like by the end of chapter 5, we'll have made a lists application that can only support one list, which is, you would never do this in real life. But what I'm trying to illustrate is that TDD can help you or can save you from having to be smart all the time. And so I'm really not saying, look, you should be stupid when you're coding. I'm saying, sometimes you can get away with it, or sometimes TDD can help you, even when you are accidentally stupid. So it's the same idea as the sort of ratchet principle, and that your tests can guide you once you've written them and you can code drunk or whatever it is. So where we are, okay, so in the first half, what have we done so far? We've done functional tests, we've done unit tests, we've had Selenium, we've found a few elements on the page, we've managed to input stuff into a text box, we've done some refactoring. Have we seen the TDD diagram? Have you guys all seen that? Let's have that. I was quite pleased with that. That's near the end of chapter 4, I think. Okay, zoop. So over there, can you see guys that? So this is the kind of overall test-driven development process. Write a test, run the test. Well, does it pass? Does it pass? Probably not. So in which case, I write a tiny little bit of code, run the test again. Does it pass? Nope. Write a tiny little bit of code, run the test again. So that's the little unit test code cycle that we were in, sort of like in chapter 3 there. And when it finally does pass, when you finally got some passing tests, there's this important stage where you go, okay, well, this code that I've written, does it need refactoring? Like, is this quality code? And if it does need refactoring, then you can change your code and keep running the test to make sure you haven't broken anything. So that's what we did when we changed, for example, from using a string to using a template for the home page. So that's the general TDD process, but you'll notice this kind of doesn't really talk about the difference between unit tests and functional tests. So what is, so I'm sorry about the flowchart, but I did spend 5 years as a management consultant, so I just can't help myself. But I promise you that the next one will feature recursion, so it's going to be pleasantly programmer friendly. Look, what's the overall TDD process? Well, basically that same process is your functional testing process, and within that you've got a little mini TDD process, which is your unit testing process. Right? So when we write a functional test, we run the functional test, that fails, then we go into our code or application writing mode, which is where we write a unit test, and we see if that passes, and then we write some code, blah, blah, we do a little cycle in here, and then we come up to the overall cycle. And so that means you can do refactoring at the level of an individual function to change how a function works, but you can also refactor your whole application. So your application still does what it does from the point of view of the user as it did before, but you might change all your unit tests. So you can do kind of top-level refactoring as well as bottom-level refactoring. Does that make sense? Well, we're going to be doing a little bit of the overall level refactoring in the next couple of bits. So this is my hope. What have we got? An hour and a half? Hour and 15?
Until 6:30.
Until 6:30 or 6:20.
Yeah, 6:20.
We've got 1 hour. Yes, sir.
So is it sometimes not difficult to figure out, you know, what
Where am I in this thing?
tests to write before you have to code?
Well, how are you going to figure out what code to write? Like, so why should one be simpler than the other? So, it is a change of mindset. But really what you're doing with your tests is you're saying, what's my specification? What's my objective? What do I want this to do before I do it? So in the case, for example, of, in the case of your functional test, it's very easy to write that before you write any code, because the functional test says, what functionality do I want on my website? Okay, I want a home page, I want to be able to input a list item, I want to be able to hit refresh on the page, I want to be able to see them in a list and a table. So all that is that's easy to write before you write your code.
Or what if you don't have a clear idea yet and explore?
So there's a separate thing from like sort of this rigorous TDD process is you can do exploratory coding. When we're doing extreme programming, we call that spiking. So in extreme programming, we do everything as pair programming, so there's 2 people sitting at one computer working together, and we do full TDD for all the application code. Now every so often, you want to do something like go and look up a brand new library, or like switch from NFS to GlusterFS, which is what we're doing now. None of us know how to use GlusterFS, and it's pointless to have 2 people trying to write tests for something we've never used before. So yeah, there is room for like exploratory coding, going and trying something out, hacking something together to understand the API. There is room for that, but what is that? That should be a prototype which you then throw away, and then you should be in a position to write the test for your application. The other thing is that you should always be possible to write kind of your high-level tests, and then get down to the lower ones. And then in terms of, I'm not sure what I want yet, what that tends to be is maybe more kind of cosmetic stuff. So if you look at what our functional test does, it says, right, well, if we're going to write a to-do list app, I need at least some kind of box that I can write in, and then it's going to display the results, some kind of list on the page, right? And now you might not have decided whether it's going to be a text box, or it's going to be whether it's going to appear in a table or in some kind of bullet point list, but you could probably like define some high-level requirements quite early on. And then if you want to change, what color it is, or what font it is, or what the size of the window is, that's all stuff you can do, you can explore, and that you probably don't need functional tests for. Does that answer the question? Mostly. Very good. Anything else? Any kind of reflections? Has anybody, had their coffee, maybe a cigarette, I don't know, maybe a cigar during the break, and sort of been thinking back on the first half, going, yes, I wonder if, is that occur? Yes.
I actually wonder, because I spoke with my friend, and he says that Selenium sucks. Because basically, you cannot do it headlessly, totally headlessly, because you still need the X server.
Yeah.
And my...
So first of all, that's not true. I believe that Selenium does have a driver which you can run fully headless, which I think is called the... it's not Firefox, it's not Chrome, it's like called HTML something, which is like a fake browser. Fine.
let's say behavior is not,
Hmm?
because mostly I develop for remote VPS.
Yeah.
I'd like to have the same result.
Yeah.
So, what do you think? Have you checked the product like Ghost or Ghost Python?
No.
It's actually the filling gap after the Python.js
Oh, yeah.
dropped the support for Python.
Oh, okay, I see. Yeah, I mean, so where we are is we're building an app which is a GUI app for real users. So Python Anywhere, that is an application that real people are going to use with a real web browser. And so we're quite comfortable with running our functional tests because we really want to see that it works in a browser. If you're building an app that's much more of an API, maybe you don't need Selenium. Your other question is, well, I want to be able to run my tests on my development server, like headless. Well, we don't run Selenium tests on our servers at Python Anywhere. We run the Selenium tests from a normal PC, and they talk to the server remotely. So you don't need to run your Selenium tests and your server on the same machine, especially once your project is a bit more complex. Yeah, so...
Basically got your branch,
Yeah.
the local ones.
Say what?
You rather have your on local side, your branch.
Yeah. Well, so you might even have two completely different code repositories. You might have your server code, your application code in one repo, and your functional tests in a totally different repo. And you have, if you have an automated processor on your own machine, you check out Selenium, you check out all the functional tests, you run them from there, but you're actually talking to a server that's hosted on AWS, which has the actual code base running on it. And you can actually separate the two. Yeah, no, that's totally possible. So you don't have to be running Selenium and installing X on every single server, no. Good. Okay, well, let's have a go then. So where are we? Someone tell me what we've got to do next. Yeah. Oh, okay. So where we are is that we've got the sort of functional test running, and it's saying, oh, okay, well, when I type in a new list item, it's not appearing in the table. So let's fix that. So here's this guy. Let's go and close the PDF. Where is he? I need a mouse cursor. There we go. Alt. Okay, thank you. All right. Now it's in front of my window. I can't see. Where's my mouse? Okay. So this is the functional tests. They're failing appropriately. So we now go into our unit tests, which is going to be in test.py. So what we're probably going to have is, like, typically if you want to take some of the user's input and save it somehow, we need to send that input to the server. And so the way you do that in HTML is with a form. Is anybody not familiar with HTML forms? There we go. Fantastic. Well, you, sir, are learning an awful lot today. This is amazing. Okay. There you go. So what we've got part of a form in our home.html is the input box. But normally input boxes are meant to be inside a form, and so that's like a tag called form, right? And then the attributes of the form are method, which says how do we send it, so method equals post. All right. So for those not familiar with HTML, post and get are the two sort of methods you can put on a form. Get is, when you have a URL that's got those question marks and then Q equals this and action equals that and blah. That's a get request where you send your key values kind of as the URL in a query string, and the post request is part of the browser's request and is more secure because it can be encrypted with HTTPS. So we're going to use post for this. And the other attribute that it needs is an action, but by default the action I think is just to submit it back to the same place. We'll start with that. Right, so form method equals post is there, and we put the input inside it, we go end form. Oops. Okay. So that's our first thing. So now that we've wrapped it in a form, when the user actually hits enter on this, the browser's going to recognize that and it's going to send that input to the server as a post request saying, server, do something with this. So let's see what effect that has on our functional tests. And so you guys, you can see because it's not in the right window, but I'll show you it again. So there's some kind of ugly exception here. And depending on how fast your computer is, you might not have spotted the web browser popping up and showing some sort of error. It was a little bit too quick for us. So what we can actually do is we can go and look at this manually. So there's several, when you get a sort of unexpected error like this in Selenium or in any test, you've got several little sort of test debugging techniques. One of the most obvious ones, you can put print statements, and you could maybe write a better error message. You could change your tests to try and learn a little bit more about what's going on. What we're going to do is like one of the most boring and silly, which is we're going to put a time.sleep into our test to sort of slow it down and see what actually happened when it opened up the window here. So if I just go back here, it failed at line. Do you guys still see that? Oh, stupid T-Mux. You've made my life harder, you have. There you go. It's made the post request. We can see that in the little tracer. So it's saying, well, I can't even see that. But anyway, if I could see the line number, it would tell me that it's failing about here. So here we're going to basically put import time.sleep, and we're going to say 30 seconds, whatever. Hup. Let me just pop that again. So I'm putting a little time.sleep just before the error occurs, and that's going to pause Selenium, and then I can actually look at that window that it pops up and take a little peek at what's going on. And what's going on is this. Right? just after it's hit enter, it's giving us this Django error. And it's saying CSRF cookie not set. Who knows what a CSRF security problem is? Yep. So this is quite cool. This is where I do a little plug for Ross Anderson. When I studied computer science, finally, I was allowed to choose what modules to have in my course, and I decided to do the security module kind of out of a sense of duty, because I thought, it'll be boring, it'll be really dry, but it's important, so I better do it. And I was really surprised that the security module was the most interesting one. By far, possibly apart from artificial intelligence. But it was actually absolutely fascinating, because security isn't just this sort of like boring thing. It's really about hacking. It's about using systems in ways that they're unintended. It's about being a really devious-minded person. There's a wonderful Bruce Schneier example where he goes, one day when I was a kid, I was amazed that I found that you could buy an ant farm. And what it was, you go into the shop and you would buy the ant farm, and it would have no ants in it, and they would come with a little card, and the card you just filled in, you put your address, and you put your address on it and mailed it off to them, and they would mail you back in the post some live ants in a tube. And I thought, so my friend thought, well, that's amazing, I can't believe they send live ants through the post. And I thought, that's amazing, I can't believe they send live ants to a random address of your choosing in the post. Right, and so he'd figured out this was a great way of getting live ants sent to scared relatives or whatever. But so there's a little way of abusing a system. And so that kind of that, it's such a joy. And so so the textbook for this course was called Security Engineering by a Cambridge professor called Ross Anderson. It's about 3 inches thick, right? And it's just an absolute page turner. So if you guys have never read anything about security, buy that book. I promise it's like the most interesting textbook you'll ever read. It's full of lock picking. It's got burglar alarms. It's got spoofing sort of South African fighter jets by using replay attacks. It's got how to forge banknotes. It talks about cryptography and its use to maintain high price levels in the printer inkjet market. I mean, security engineering. Security Engineering by Ross Anderson. I believe there's a little link in the PDF. And there's a full 2-paragraph rant about this in my book, which I can only recommend that you read. Yeah. Well, it is actually available entirely for free. So there's no subverting the system there. It's just publish, Creative Commons, help yourself. You're very welcome to have it free. Of course, if you'd like to pay for it, my publisher would certainly appreciate that. Well, there's a lot more in the book than there is in the course, including the full details of Ross Anderson's security engineering. Okay, so CSRF is basically saying, you might be able to pretend from a different website, that you're submitting a form, and the cunning way around it is to say that each request that sends to the user has got a little signed key saying, this was really for this user, and if you send a post request, you must include that to prove that it was really from the same server that you're sending the request back. It's to stop, I think, session hijacking or something. There, smart. The details are probably fun to look into. So CSRF, so how do we deal with that? Is that we just put a little tag in the form. So home. Yep. So this is just a little bit of Django magic. I must look this up and be able to tell a more convincing story about this. But basically, this is going to say that when Django renders this page, it's going to put this little magic token, which is going to add security to the form. And then when we resubmit it back, we can be sure that it was the same user that we sent it to that's sending it back, or more sure. So if we just pop that, CSRF token, and this is the first time we use the Django template tag syntax, featuring the world's hardest 2-finger touch typing combination, namely the left pinky finger shift, right pinky finger curly bracket, right pinky finger shift, left index finger fire. Just why would they choose this? Honestly. CSRF token, good. Let's see if that does any better. Zip. And then what happens is, we've still got the time.sleep in there, so nothing is actually what happens for about 30 seconds. But at least the CSRF error isn't there anymore, so we have fixed it. Hello, Peter. But by the way, guys, can I have a little round of applause for Peter here, who has been my glamorous assistant all evening, and a wonderful, wonderful man. Oh, yeah. Curses. Yes, we could do that. Just almost in time. Yeah, well, just out of curiosity. But it's a long sort of cryptographic hash, basically, or just a long yeah. Right, fine, blah, blah, blah. You know, this is still saying that, you know, you still haven't actually managed to put anything into the list table. We've done the CSRF token, but we're no further forwards. The next stage to do is to actually say, all right, well, we now need our view to take this post request and save it somehow. So that means a new unit test. Let's do it. Views, tests. Look at me there, almost going to views.py instead of test.py. See? You have to constantly force yourself to do TDD. It is a discipline. All right. So what we're going to say is test that the home page can save a post request. And so is this the point, remind me if where I start using the Django test client or not? No, not quite yet. But we haven't got an awful lot of time, so we could use it here. No, let's do the next one. Okay, so request. Request.post. There you go. So .post is a dictionary, so when you send things from forms, they tend to be key value types of items. So what we're going to do is have, so it needs a key which is going to be like item text. And that's going to be equal to, you know, a new list item. Okay. And then we're going to take this same response as homepage request. And we're going to say, well, new list item. Yep. So what's going on here? We created an HTTP request as before, but this time it's got a post. So we're stimulating what happens when the browser submits that form. It takes a key and a value, so the key, actually I need to pop that back in my home page.html. So yeah, home HTML would normally go in, the key is the name attribute of the form here. So that way if you had multiple inputs, they would each have their own sort of key values there. And so I create a post item, and then the new list item is the equivalent of Edith typing in, you know, buy, you know, milk or buy fly fishing feathers or whatever it was. So we call the function, and we're saying, okay, well, when I send you a post request, what's the minimum thing that I expect? Well, you know, the response that comes back should have the table in it, and that table should list the new item. So this is the quickest little test that we could write for that. Okay, so let's try that. How would we get that to pass? Let's have a look at views. So we're going to have a request.post that's going to be available over here. All right. And we want to, I mean, like the real simplest way to get this to pass, we could go if request.method equals post. And we could do return an HTTP response. Now this is a deliberately silly item text implementation. And then we just need from Django.http import HTTP response. Okay. So would that work? I really must stop running the manage.py script in the same window as this. It keeps polluting the screen. FG1. What? Oh, I've forgotten this guy. Is it? FG2. FG2. FG1. Is that it? FG. Aha, there he is. Clunk. Let's put him in a different window. Okay, temp TDD workshop, cd/temp. And we're going to Python manage.py run. Okay. Yeah, function test. So now we got views. That's what I've got a random. Basically, I'm probably the only person in the world that likes this, but I like. I've got 300 color schemes installed in Vim. I like to start out with a randomized one each time. Some people think that's weird. Whatever. Okay. Very good. So this is like a deliberately obviously this is not the way you'd do it. But I'm just sort of proving that if you do something deliberately silly, at some point your tests are going to save you anyway. So let's just make sure that that would pass. Test lists. Okay. So what's happened here? New list item. So I think I forgot to set request.method over here. Tests. Yep. Okay, cool. Well, that passes, but we know that would be a ridiculous way of running things. So what we need is our little home page request here should be like a little bit more expanded. Obviously, we don't want to be just returning the string of the request. We want to say, let's put the new item into the home page table. So let's go and open home.html. We've got the table here. And what we're going to say is that we should have maybe a table row. And we're going to have like maybe a table cell like this, and it should have the new list item in it. And so this is we're going to learn, use the Django template syntax really for the first time, which is that, like a sort of inverse PHP, the Django templating language allows you to introduce Python variables during the rendering process. So what we're going to be able to do is say, not only render this template, but also pass in the following values to the template so I can display them wherever I want them. So in the table row, I'm going to display our new items. So what we're going to call it is maybe new items, something like that. What does it say in the, I wanted to have this more or less the same as what I've got in the text. New item text, I've called it. Okay. Right, ship, TD. Okay. All right. So I'm going to have, so this is the second Django template syntax. The one with the curly bracket % is for sort of commands, and the one with double curly brackets is just to display variables as text. So what this is saying is that this template expects a variable called new item text, and we're going to display its value inside that TD. All right. So the way that's going to work in the view, or the way that's going to work in the tests, is we're going to say that probably the better way of doing this is to use the Django test client, so we'll go and do that now. So we've got a test case. So basically, when we start passing attributes to templates, we want to be able to make assertions about how did we render this template, what were the variables that we passed to it, and the Django test client will help us do that. So we can transform this slightly and say client equals client, zip, and we're going to go client.get, client.post, and to slash, and the data is going to be equal to this thing here, zip, zip. There you go. And then self.assert render. What's it? Assert render template was something like that. F6. Render. What is this rendered with method? That's in chapter 6. Yeah, okay, alright. Well, maybe we won't do that then. Shouldn't just skip ahead at the last minute during your thing. Just stick to the plan, Harry. That'll just be safer. Alright, so we'll just do this. Keep the boring way. And we'll keep going like this. So request. So what are we saying? We want to make sure that not only is a new list item in there, but also that it's still using the home template. So we can use these two bits here. Shoop, shoop. Okay. And then what we're going to say is when we render that template, we're actually going to pass in the variable as context. And so this is the place where you would have new item text is, let's put that onto 2 lines so it all fits. Shoop, 1 comma, shoop, shoop, hoop. And that's going to be, what was it? New list item. Okay. Okay. So what have I just done there? My first test just said, okay, well, make sure that the new list item appears in the response. And my second bit is I make sure that the response is still the results of rendering home.html. But the new thing is that we're saying we're going to render home.html with new list item as its, with the new item text being a new list item. Now this is a little bit confusing, right? There's a lot for people who've never seen the Django template syntax before. I'm now going to implement this, and then we'll go through it step by step to make sure that we understand all of it. Okay, so let's see what that looks like if we run the test. Fine. So at the moment, we're just returning a single little string, a new list item. Obviously, that's not our template, so that gives us the justification to go and replace our nonsense implementation with something real. And so we're going to say something like new item text equals this, and then the return, and we're going to go, and so then this takes a dictionary as its argument, where we're going to have new item text, okay, else, new item text, that's blank. All right, fine. So what are we saying now? If it's a post, let's extract the new item text, and then we'll pass it into the template over here. The template will get the new item text from the post request, and it will be able to render it into the table. Okay. Let's see if that makes the test a little bit happier. Why not? What? Come on. Did I make a spelling mistake? Yeah, what did I do? Home. Thank you very much. Who spotted that? You didn't tell me, let me go wrong? Well, you knew that TDD would save me, right? Yeah, exactly. Thank you very much. Da-da-da-da. Now what? Come on. That should... A new list item, introduce item to a new list item. I've probably just spelt that slightly wrong. Thank you very much. There you go. See, this is why we do pair programming, because, well, basically, I'm a little bit thick, so if there's somebody there with me, then we tend to get to having the right code eventually. Where is this asserted? Thank you very much. I wish I had a little Vim shortcut for swap 2 arguments inside a... don't you? I mean, there must be like... sure. Some sort of Vim macro should be able to do that, but, you know, you can never quite cover all the use cases. All right. Much better. Okay, so there we go. We are now, we've got a unit test passing. The unit test check that if we render home.html passing in a new list item, it matches what we really do. And in the real thing, we're saying, okay, look, if we get a request, if it's a post, well, let's get the user submission out of the post dictionary, and then let's pop it into the template using this new item text variable. And we can maybe look at them at the same time here. Home, hub. And then that appears in the list table. We're going to pop it in as a TD. Now, you guys are smart, right? You can probably spot that there's going to be a few problems with this implementation. So far what's going to happen is like there's only one possible list item. So this is obviously not going to work for the long term. But it is the quickest thing that we could do to get the functional test to go a little further. So what you can imagine is that this is like a tired programmer or something who's just going, oh, what are the functional tests when they, oh, okay, well, I'll just put it into the table. That happens. Sometimes we program tired. And what we're going to find is that the functional tests will progress slowly, and eventually they're going to tell us that, you know, you are getting it wrong. You're going to need to change your approach slightly. And that's also going to be useful because it's going to teach us how to do refactoring of the application. We've got a solution that's not quite right. We're going to be able to go incrementally and step by step towards the correct solution, but always making sure that we have code at a working state that goes from working state to working state. So this again is a way of avoiding being refactoring cat. If you've got something that works, but it's not quite right, and you want to change it, there's often a temptation to change everything at once and throw everything away and delete it all and start again. But that's the way to find yourself sort of 15 steps down in the tub and not be able to get back out. So we're really going to see the step-by-step approach to getting it right. Fine. So what will happen with the functional tests then at this point? Let's close that one. Yeah, functional test. Functional test. Yep. By peacock feathers. Okay, you guys can't see that, but it looks like that. I think I've still got the time.sleep in there. That's why that's taking forever. But there you go. Look, this is starting to be a list sap. Look, I type something in, and then it actually appears in the page. Well, it's pretty exciting. Like, has anybody? I mean, we could try this in real life, couldn't we? Like, maybe while we're waiting the 30 seconds here, we could try and enter a new one. Look. Oh, too late. Damn. Okay. So it's saying new item did not appear in the table. Well, it did. We just saw it, right? That it was definitely there. So, like, what's its problem? We definitely saw that appeared in the table. Let's go and take a little closer look at functional test.py at this point. Functional tests. Let's get rid of that time.sleep that's taking forever. Okay, so this is the line at which it was failing. And it's saying, okay, it wants 1 colon. Right, because we're going to have an ordered list. And so we've inputted by peacock feathers, but it wants 1 colon. Like, so it might not have been that obvious what this is. So what we really want to do is that when it fails at this point, we'd like a better error message saying, oh, dear Harry, I was looking for the following text, but I actually found this text. And so we could adjust this message by sort of, instead of finding a new item did not appear in table, we could have actual text was colon, and then you can have backend %s, and you could % the, like whatever table.text or something. But as I was sort of rewriting this, one of the first readers of my book goes, well, you know what, Harry, like this whole sort of assert true anything, that you think you're so smart for, like couldn't you just sort of summarize that as a simple assert in, like 1 by peacock feathers, like this. Zip, 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 zip. Row.text for row in rows. Was it a table.rows? Rows. Wouldn't that be like a whole lot simpler than your clever assert true any list comprehension dance? Like just here are all the rows, and then the assert in would actually give you the error message. And I went, yeah, actually, embarrassingly, I was trying to be a bit too clever. And that's an important programming lesson. Whenever you find yourself a bit smug over a piece of code that you think is particularly clever, it's probably not clever. It's probably just overcomplicated. And so this is a sort of Zen of Python thing. It's like you should just try and make your code obvious. And whenever you're feeling clever, that's like a bad sign. There we go. So 1 by peacock feathers. So if I were to run it like that, we would probably have a much better error message. Let's have a look. 1 by peacock feathers, not found in by peacock feathers. Now it's obvious that I need the 1 colon. And so how should we fix that? Oh, we need some kind of for loop counter-y thing where, no, I think I'm actually just going to hard code a 1 colon. How about that? All right, so we'll do that. Now, see, there we go. Fine, finish test. Ha ha ha. Okay, good. Right, so I have actually got an app there that we can use. Let's have a look at it. If I open up Firefox. Have you guys done this yet? Have you tried visiting the site manually? Let's go localhost. Because I sort of mentioned this in the book, but I didn't mention it today. And it's not necessarily obvious to everyone, but there is actually a real web server running here, and you can actually see it yourself. It's not just the magic and voodoo of the functional tests. In fact, this is something you sort of sometimes forget, is that there's a real website here. And one of the dangers of functional testing with Selenium is that you forget to go and visit the website yourself, which means that you miss sort of things that are obvious to humans and not obvious to computers. So it is important to every so often go and try out your application yourself and go, oh my God, it's really ugly, which is what we fix in Chapter 7. What can it do, this little to-do list site? Can I go, first of all, there's a sort of 1 colon knocking around there that doesn't look too good. And if I sort of go, get get on with it and stop nattering in your tutorial. There you go. That's great, but then if I try to enter an item 2, let's do that, yeah, Wibble. Ah, okay. All right, so far it's a list that can only support one item, which is a little bit weak. So, how do we explain this? I talk a little bit about red-green refactor is one of the ways that TDD is sometimes taught. If you remember the little diagram, we write a test and see it fail. That's what they call red. We write the simplest solution that we can think of to get it to pass. That's green. And then refactor is the third step. So when you do something deliberately wrong and you know it's wrong, just to get the test to pass, refactor is maybe the bit where you're going to write some code that actually works. That's one way of looking at it. The other way I like to think of is triangle. So where we've got here is we've kind of got to the red-green stage and we haven't really done the refactor. The other way I like to think of it is a process called triangulation. If your tests let you get away with writing some stupid code that you know is stupid, one solution is just to refactor, but another solution would be to maybe just slightly extend your tests so that they stop you from writing stupid code. So the example that usually is like, let's suppose you have a function called add, and you have a test that goes assert add 2, 2 is 4, and then you define add as def add, return 4, there's not necessarily obvious how you refactor that. So you might just write a second test where you go assert 2 and 3 equals 5, and that justifies you from changing it from return 4 to return a plus b or whatever. Did that make any sense at all? Really? Can't possibly have made any sense. Anyway, thank you. Okay, well, so we'll see it in real life. So what we really need to do is like to actually force ourselves to write a better implementation, we just need to write a second test that says, oh, can you save a second list item? No. All right, back to the drawing board with your code, you. And that just makes sure that it's a sort of smoke test or a sanity test to make sure that your code really does what you think it does. FG, functional test. Okay, so where are we here? Self.fail, finish the test. So basically we want to do something that's very similar to this here. So we're going to go up, and here we go, change in here. I'm going to use P. Why not? What? Oh, God. Okay. How about now? Aha. Okay, so what have I done there is I've, let's just undo it a few times. So I've done a copy and paste of the code that sends keys all the way down to the assertion. And then I'm going to do this to say, use peacock feathers to make a fly. Okay. Dip, dip, dip. And then this stuff here. Shoop. Oop. Shoop. There we go. All right, so we fill in the next two steps in the functional test, basically. Still a text box inviting her to add. So she adds a second item. Maybe this should go up with this one. That'll look better, won't it? And we find the list table again. And then this time we should say that, okay, maybe there's a second item, 2 colon, and this should say, use peacock feathers to make a fly. Yep. And while we're at it, we might check that the old one is also still there. There we go. So I'm put the self.fail here. Okay. So we're extending our test from testing that you can just do one item to testing that you can do 2. And now we expect that. It should say, Harry, don't be ridiculous. Your list only supports 1 item. Zip, zip. Okay, what's going on here? Let's try it again. Oh, I think I've got a, yeah. So, okay, that little bug there, it's quite interesting. If you ever see this in Selenium, element not found in the cache, and what that tends to be is that you're trying to use an object from a page that's already been refreshed. So it's quite a common Selenium error. And that's saying, you're trying to use something that's gone. It's gone off the page. And I'll show you exactly where that happened here. Is when we type, let's see, so we've done by peacock feathers, the page refreshes. So this input box object here is the one from the very first page we load. When we hit enter, the page refreshes, so that input box is actually invalid. It's like off an old page. So when I try and reuse it again here, that's when it says there's no such thing. So each time the page refreshes, you need to fetch those items again. Selenium isn't clever enough to just sort of guess that you need to reattach them or whatever. Does that make sense? So that's okay, we can copy that. Pop. There we go. And try again. Zip. Zip. Okay, fine. There you go. So now what's happened is like the problem has become really obvious. Our whole application can only support one list item. So now, you know, what are we going to do about this? Well, you know, we've managed to make it so you can take a post request and redisplay it back to the user. If we want to go and save more than one, we're going to need some method of saving stuff from one session or from one page request to the other. And so a traditional solution to this is a database. So I'm sure you're all glad that we're finally learning how to use the database. It is now chapter 5 and about, what, sort of 70 pages into my book. But, you know, I really wanted to make sure we took a step-by-step approach. We do get there in the end. So the database, hooray! Who loves databases? I love databases. Yeah, big time. You know, I've got a hard on for them. I wrote my master's thesis on database spreadsheet integration, which is a doomed theme, but I thought it was pretty cool. Anyway, so databases, yay, okay, and we're going to learn about the Django ORM, which is a wonderful tool, one of the best things about Django probably. So let's go ahead and do that. Now let me remind myself of how I decided to do that. Show processing for 3-stage refactor. Oh, okay, yeah. Before we do that, we do have a sort of code smell here. Does anyone know what a code smell is? Yep, a couple of people. Code smell, bit weird. I wrote that in the book at first, and someone went, what? It's code smell. It's like something, you know, you develop a programming nose the more experience you have. But in general, it's like a sort of pattern that you notice in your code that is like, lets you worry that something is wrong. And the code smell here is repetition. We've got this sort of self.assert in, like fetch the table, fetch its rows, assert there's an item in it. Fetch the table, fetch its rows, assert there's an item in it, assert there's an item in it again. And like, the other rule here is 3 strikes and refactor. So when you find yourself duplicating code, sometimes that's okay, like if you just copy and paste something once. But if you copy and paste it twice, there's probably a good candidate for doing a bit of a refactoring there, making some kind of abstraction. So here we really need a little helper function or some kind of thing that's going to remove all this duplication. And so in a sort of unit test, you can use other methods on the class to do whatever you want. It's only the one that starts with test underscore that's an official test, and everything else you can have as a little helper method. I like to start it with an underscore like this, or did I do it? Yeah, so check row appears in list table. And so that's going to take self and row text, or maybe it's expected row text. Yep. Okay. And then we can go and grab our little table-y code. Where has it gone? Here we are. Up. And pop it up here. Okay. Browser, yep. Self.assert in, and then this becomes expected row text. In fact, that'll all fit neatly on one line now. Lovely. Okay. So we can make a little helper function like that. Diddly-lee, will save us from fetching that table thing every time. And now we can basically use it wherever we were before. Self.check row appears in list table, and we pass in. Yep. See that? Shing. Ha-ha! Well, that's better, isn't it? Okay, and then we can use it over here. Zip and zip. Shing. Ha-ha. The other way we can know that was a good idea is that's probably saved us about 4 or 5 lines of code. So if we were doing our commits like we ought to, you should always feel good whenever a commit takes away more lines than it adds. Fine. So that's a little story of 3 strikes and refactor and code smells there. That was sort of refactoring our functional tests, so we should just rerun them and make sure they still do exactly what they used to. And it does. There you go. Fine. So that was a little functional test refactoring, and we now need to make sure, yes, okay, we're back to talking about the database, which we love. So the database. Okay, right, well, let's go and write our first ever unit test for using the database. And the side effect of this unit test is that it's also going to teach us about how the Django RM works. You could definitely write a simpler unit test than this, but this is a sort of teaching tool. So we can have a new test class. And what we're going to do is we're going to want to save list items, aren't we? So this is going to be, we're going to need a model for that. So it's item model test is what we're going to call it. Unit test, not test case. And so this is test. So let's see, saving and retrieving list items. So if we go item equals item. Who here has already used the Django ORM and knows all about it? So who's never used it? That's more interesting. Never used the Django ORM? Fantastic. Okay, good. Who knows what, do you guys know what ORM is at all? Okay, no? No? Object Relational Mapper is what it is. Like in general, what is a database? It's a bunch of tables and columns and rows. And you typically query it using SQL, which is a weird language. And SQL doesn't look a lot like Python or object-oriented code. And so the Object Relational Mapper is saying, well, let's look, it's a way of viewing database data that uses the familiar kind of object metaphors that we're all used to. And so it says, look, instead of dealing with SQL, what we'll do is, you define some classes and some objects, and that will be the way that you save your database data. And we're going to see how that works in real life. So basically, instead of, if I wanted to create a new item and save it in a database using SQL, I would do something like insert into table items, values, item, blah, blah, blah. But instead, we can use lovely little objects, which we love. Yes, a lot of love in the afternoon session, isn't there? It's a good thing, I think. Okay. And so we instantiate an item. We give it an attribute, which is, say, going to be, for example, what do I call this? Item.text equals buy milk or whatever. And then to save it to the database, we call .save, which is going to have a special method. Okay, and then next we're going to test how we can, so that's how you would create an item and save it to the database. It's going to say, well, I'm going to make an item which, and its main attribute is going to be its text. In future, that item might grow. It might have like a flag for whether it's completed. It might have a number on it so we can store what order they were saved in. It might have a timestamp. It might have all sorts of things. But for now, it's just got its text. And then to retrieve one, we go item in DB equals item.objects.get, and so the let's see, how do I do? I think like this. ID equals item.id. And so what's happening here is that this same item class that we're going to define inside models.py not only lets you create objects, but it also lets you query the database. And it does this by a special sort of class method called objects. And so this is the way of saying, find me all the objects in the database whose ID is the same as this ID. In other words, that's going to be the same object. But in this case, I've just created it, and down here, I've gone back to the database and retrieved it. And so I'm going to test next that it's really saved the values that I care about. Item in db.text is going to be by milk. Okay, so two things here. We need to import unit test. Oh, yeah, okay. And then from here, models. Item. Okay. So here we are. So an item object that we create via Django's magical auto-ORM automatically gets an ID attribute. That's going to be the database is automatically incrementing ID for its row. And we're going to say, okay, well, I know that I've tried to save it here, but let me just double check by getting it back out of the database and asserting that it really has saved the item text. Does that make sense? Who thinks it almost makes sense, but they're not quite sure? Okay, well, let's just see how we get on when we actually try and do it. First of all, let's try and run it. What will happen when I run this? Anyone? Correct. Cannot import name item. Good. Who knows what we do next? And how do we do that? Oh. What file? Okay, what do I write? Mm-hmm. No. Come on, you saw this before. We write this. Oop, none. Oh, it's not going to do anything. Item equals none. See, it's just the import error. Oop. Ha-ha. Okay, obviously, the very next thing we try and do is instantiate it. But like, this is really making sure that everything is justified. So same story. Import error, item equals none. Next step, when we use it, then we'll find out what type it has to be. So, none type is not callable. Well, I could make it a lambda, but that's taking it too fast. So we want to make it a class, right? So let's make it a class. Item. And pass. Right? That's a minimal bit of code there. Ship. All right, so then it's actually got quite far down in the test, right? So I've made a do nothing class. It's not a Django class or anything. And the test has actually got quite far. It's got to line 45, which I have a look back at tests over here. And it's like, it's created the item, it's assigned the text to it, and it's got as far as trying to save it. And so you're like, well, you might have expected it to fail here, you know, without thinking about it. But of course, once you've got an arbitrary object, you can assign any value to it you want. So this is just a do nothing operation at the moment, and it's complaining that item.save does not exist, right? It's saying, you know, this item object has no attribute save. So what's the simplest way of giving it a save method? Well, we'll make it inherit from the Django model class. There we go. All right. So in models.py, this is where we define our models, which are going to map to database tables. And here, this is the absolute minimum kind of model you can have. It's got nothing in it. It's just saying we're going to have an item. And that makes us an item table. And it inherits from models.model or your models wall. And now if we run it, it actually, again, gets surprisingly far down, or perhaps surprising. It's now got all the way to line 48. So let's go and see how that happened. So it's created the item, it's done item.status by milk, and then save. It's gone and fetched it from the database, so Django has managed to save a value to the database, and then it's just moaning that it doesn't have the attribute text. Okay? So what's happened there is, we've taken an item, we've assigned an arbitrary attribute to it here, but when we save, it's immediately forgotten that. And we've managed to retrieve it, so there is an item in a database, and it does have the same ID as this one we created, but it doesn't have the text attribute. So you say, because, you know, that's just sort of disappeared into the ether. If we want it to actually save that attribute, we need to make this attribute.text magic, and that happens in models.py, where we say, okay, look, the attribute text over here is going to matter to us. And this is where we get into sort of Django's declarative syntax. This is where we're saying, okay, this is where we define the item class, and this is where we define the properties we want to have on it, which are going to map to the columns in the table. So we're going to have a table for items, and then its attributes here that we're about to define are going to be the columns in there. And it's a models.text field. There we go. Zip. All right. And so any of you that have worked with databases, there's all sorts of other field types. You can have a models.integer field if you want to store integer data. There's a models.boolean field. There's a models.datetime field, which is a bit more useful. Ever since modern versions of Django, that really gets to be a pain in the ass with time zones, but you know, it's all for your own good. There's, what else is there? There's like a sort of regex field that will only ever accept things that match a regex. There's a models.email field, there's a models.url field, and they'll do all sorts of clever validation to stop you from inputting data that's of the wrong type to it. But for now, we just give it the item text. Models.text field. There's also a models.char field, which will map to MySQL varchar, but you can get a bit too deep into it. This is the simplest way of saving a bit of text data. Let's try that. What? What have I done wrong here? Okay, what? Extra where? Ah, thank you, yep. Yeah, it was actually trying to tell me that as well, wasn't it? Yeah. Okay, haha, that passes. Okay. Very good. So that has now made us, we can now save items and save their text into the database. So there's a little start there. So now we can actually use those in our views, right? So let's go ahead and do that. Let's see. So back in our list test. Do you guys want a little bit of time to catch up, or shall I continue with the view one and then leave you time to catch up later? I'm in the flow here. Come on, we're going to keep going. Yeah? Okay, good. So over here, in our test that says test the home page saves a post request, perhaps it would be more useful to say that, you know, like as well as checking the response has it in, why don't we go and check at this point that it's saved an item in the database. Objects.get, or maybe let's just go and fetch all of them, and then the very first one, because, so I should say at this point that in your Django unit test, Django creates a database for you to play with, and before each test it cleans it out completely. So every single test that you run in the Django test runner has got a clean database each time. So I know for sure that when we start, there are no items in the database, and so at this point, if I get it, it'll be the only one. Yes, it's an in-memory SQLite database, so it's super fast. Later on, if you start having some hardcore dependencies on, you know, like Postgres or something, you might want to run some of your tests with the real database, but, you know, more complicated topic than we've got time for today. So in fact, yes, what we'll do is I just go self.assert equals item.objects.all.count 1. Ta-da! How about that? And then if we do self.assert equal, so if we're going to do this, item equals item.text, a new list item. There we go. Okay, so we're extending our little unit test for the post thing here. We're saying, all right, well, you know, apart from maybe cheating and passing the post request directly to the template, let's make sure that after we've sent a post request to our view, we actually have an item saved to the database, and that, oh, sorry, this is wrong, yeah. And that item's text is a new list item. So a couple of new things we can learn here. The item.objects also has a .all method. We used .get earlier, which is a way of querying and trying to find exactly one object. .all just returns every single row in the table, every single object you've saved. And then that response there, the result of that all function is a sort of list-like object called a query set, which you can iterate through. You can pick out the 0th item from, but you can also call .count, which tells you how many items there are. I could have called len on it as well, but .count is the same thing. So we think this is going to be 1. We're going to fetch it, and we're going to say, has it been saved? Okay, should we try that? Does that make sense? Okay. Manage.py test list, 0 not equals 1. It's not saving anything at all. Okay, so let's go ahead into our views, and say, okay, well, if the request method.post is post, well, we probably want to save one. So we'll go item, and so earlier we used item equals item and then item.save. There's a little shortcut to that, which is item.objects.create. And we're going to say text equals new item text. Okay, I know that. We're going to want import item here, so we're going to Hampshire from list.models import item. Does that make sense? This item.objects.create? That's exactly equivalent to doing item equals item, item.text equals blah, and then item.save. And it's just a little bit quicker. Please say no if that didn't make sense. Yeah, okay. So that's going to save the item magically. Yeah, bro, what about that? Fantastic. So that's item in the there. But if we rerun our functional test, we're still not going to get any further because, like, we might be saving items to the database, but we're not actually doing anything with them. Oh, I've lost my server somewhere. cd/temp. So do you guys see that error there? Do you know what's going on there? Yeah, exactly. So I think I've managed to accidentally close the window which is running the server, so I'm just going to go and start that again. That happens quite often. Python manage.py run the server. Django does come with an automatic way of starting up the dev server in your tests, which we look at, I think, in chapter 6. What's this nono is not defined? How many? Okay. So where are we here? You what? Yeah, that's a bit weird. How did that happen? Oh, it said the name. Huh, did I never do that? Wow. Hey, okay, great. So this is another point at which we might have used a time.sleep or a little printing of the text, but thank you very much. Yeah, okay, so, and so why is that's a little bit weird, isn't it? Like, why is it only now that it's complaining that we need a name in the settings file? Yeah, exactly. This is the first time we're actually trying to use the database. But you might be a bit weirded out by the fact we've been running the unit test just fine, and it's not been complaining there. And the reason for that is when it runs the unit tests, like we were saying earlier, the test runner actually creates a test database, an in-memory SQLite database for you to run your tests against, and then destroys it at the end. So it doesn't care what its name is because it's just a little test database. But when we're trying to run the real server against a real database, it's going, oh, okay, I don't even have one. And so probably if I looked a little bit closer at, yeah, look, you guys can't see it. Well, if I Control-C this, but when I was running python manage.py run server earlier, okay, it was actually complaining that, oh, so yeah, if I do that there and I rerun the test, it does actually complain that settings.database is not, .name is not defined. So we'll do that. Because we've chosen a SQLite database, the name is actually the name of the file name, and I'm just going to call that db.sqlite. There you go. And that's next to the main good point. So we're going to create this database. And so the other part of the ORM magic is not only does it give us a way of creating objects using object-oriented metaphors and querying the database using those sort of object methods, but it also, models.py essentially defines what we want our tables to look like. So it also gives us a way of creating the tables. And the way we do that is another sort of manage.py command called syncdb. No. And so this is the thing that's actually going to create your database for you, and it's going to create the tables just as we've defined them in models.py, and it's quietly creating a bunch of other Django tables like the auth ones. It's going to say, ooh, look, you've got the auth system. Do you want a super user? I'm going to say no for now. And then if I do an ls, you'll see that I've got db.sqlite has been created there. And so now I can rerun my manage.py run server, rerun my test, and zip, it will be a little bit happier. There we go. But we're still no further because we're not actually using the database to display our list models. Now we're running out of time, so I'll just give you a little general overview of what we would be doing at this point. What we'd be doing is, instead of just passing the raw item text into this template, we would pass in a list of items. So you could just pass in sort of items.objects.all, and then back in home.html, instead of just having a single one here, we would start using a for loop in here, and then you can render multiple items inside the template, and that's the real power of Django's template syntax. But that is the end of the session. Yeah, okay, we did pretty good. So we've seen some of the real great stuff about Django as well. So the ORM is wonderful, and about this point we would see for loops and templates, which are great. We've covered how to unit test absolutely everything, including urls.py, which is some insanely anal testing. But you know, that's what you must do when you're learning. That's what the testing goat says. We've covered functional tests, and then there was loads more fun, but you can read about that in the book. Did you know that I was writing a book, actually? Yeah, anybody that would like, that is interested in the book, I have 40% off discount coupons, totes over here. So just come and see me about them if you'd like them. And are there any questions?
Are you planning to integrate stuff about working with South?
Yes. You can see the outline of the chapters in at the end of the PDF. So I've included the chapters that we were going to cover today. And then the last chapter in there is an outline that says, here are all my planned contents for the whole of the thing, and that includes South. What sort of happens is we do chapter 5 with us going a bit wrong here, because like you can see that even when we get to the end of this, we're going to have an application that only supports one list. Like, so one user can come along and add loads more items, but the next user that comes along is going to be seeing exactly the same items. So, I mean, it's an interesting to-do list in that it's like a single global to-do list, and you know, in a way that might be quite heartwarming, because it would remind us of the fact that we're all connected, and in a way we all share this planet together, and we really do have a common shared goals, but which is heartwarming, but not that possibly commercially successful. So we go on to the sixth part. We have a related object. So we have like a list object which has related items, and the items are related to them. Then in chapter 7, we go, right, okay, fine, we can make lists. It's time to deploy because it's all lean startup mode. And as soon as you've got a to-do list item where you can just write lists, I don't care that you can't mark them completed. I don't care that you can't save them as your user ID. If you can have a list and you can save objects to it, that's already great. It's time to deploy it, but it's too ugly. So chapter 7, we bring in Twitter Bootstrap and make it look completely generic but less ugly. And so we put in Bootstrap and we show how you can do a little bit of functional testing for some aspects of layout. And then in chapter 8, we actually deploy it. And like this is quite a fun chapter where I'm going to actually ask the users to register a domain name. Now come on, it only costs $5 and you can make it whatever you want. Register a domain name and spin up a server like on AWS or DigitalOcean or whoever you want, and go ahead and log into that and deploy your code. And so we talk about Fabric, we talk about virtualenv, we talk about how to save CSS files, we configure Nginx, we configure GUnicorn, and that all happens in chapter 8, which is great. And by the end of it, you've got a real server with your lists application running on. You can show your mum. So that's the end of chapter 8. And then chapter 9, we're going to go off and do more forms and authentication. And then JavaScript, which is going to be the subject of chapter 11, I think. Oh, and that is this.
Sorry to interrupt you, but we should finish here.
Okay.
Allow people that want to go to the keynote.
Yeah.
If you want to ask a question and stay for more, of course possible, but
Yeah. Okay. So, guys, thank you very much for sticking that through. Yeah, I am here all week. I've got the vouchers for my book. If you have any more questions, I'd love to talk about it. I'm running some kind of, there is going to be some kind of testing help desk thing